Hi everyone. In this lesson, we are going to finish the resolution of the problem 1. In this case, we will do the solution of the module D, which is the last module of this problem 1. It says, and it asks us to represent the language of the words over the alphabet A and B, such that they have an identical prefix and suffix of size greater than 0. In this case, they mean that they can't be the empty word, because if we have the empty word, then the size is 0. Then this prefix and suffix, as said, cannot be the empty word. Their size must be greater than 0, unless than the size of the word itself, right? So how do we represent this? We represent this language L, which is all the words over the alphabet AB, with the clean closure, right? Such that there is some U, which will be a subword, some V and some T that will also be subwords, such that I can express my word with W equal to U concatenated with V, and I can express my word also with T concatenated with U. And finally, to represent that their size must be greater than 0, we say that 0 must be less than the size of U, and U itself must be less than the size of the word W, which is the word that we want to accept. And this is the language L. So in order to understand properly this formalization, let's see an example of this word. Okay, so imagine that we have the word BBA. Okay, so this is our word W. It is obvious that this is an accepted word since we have the prefix and the suffix, which is the same value. Yeah, they're the same. Now, keep in mind that in here, what we're saying is that we have some UV and some TU, okay, such that W can be expressed in this same way. Okay, this is equal. Instead of 2 points in here, it is the equal operator. Okay, now when W equals to TU, then this is the T, this is the U, okay, and then we can also express W as UV. So in this case, this is the same, the U, okay. Well, in this case, what's more important to note is that in this other decomposition, in here, W is UV. So this is U and this is V. Yeah. Then when we do this decomposition, this is T and this is U. Okay, so since U is a subword that can be a suffix and a prefix, in fact, this subword must be, okay, must be a suffix and a prefix, because here we have the AND operator. Remember that this is the AND logic operator. So what must happen in here is that U must be the prefix of the word, and also it must be the suffix of the word. Okay, so with this, we ensure that there is some prefix U and some suffix U, which is the same. Okay, so they are the same. Okay, we can see another example of this. Imagine that we have the word AA, B, AB, B. So now, okay, we have this could be also the word AAB, and then we have here the AAB. Okay, so now as we see, we have this prefix in here, and then we have this other prefix in here, and well, this is a suffix, okay, but it will be the U again. So here, what's the size of this? 3. The size of this is 3. What's the size of the whole word? if this is the word, the length of my word is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9. And the prefix and the suffix, as they have size 3, we have that it is less than 9. So this is an accepted word. Okay, now keep in mind, if we do the decomposition, okay, in the formalization, then this is the U, okay, this is the U, and this is going to be the V, and then in the other decomposition, we have that this is the U, the suffix U, and this is the T, the prefix T. So as we see, we have some prefix and some suffix which is the same, is the U, okay, the subword U. So essentially here, what's important to notice is that U, the subword U, is the main goal, to have the prefix U and the suffix U, okay? So with this, we finish this formalization on the problem 1. Okay, so we have solved now the problem 1 module D, and with this we finish the problem 1.